open your eyes. At first, everything feels normal. The stars are still there, the silence of space surrounds you. But then, something changes. The universe begins to bend. Light twists into impossible shapes. The stars behind you stretch into glowing rings. Ahead of you, there is only darkness. Not the darkness of night, but the absence of everything. You are falling toward one of the most mysterious objects ever discovered, a black hole. And for the first time, you won't just learn about it, you'll experience it. Before we continue, forget everything you've seen in movies. Black holes are not giant cosmic vacuum cleaners. They don't randomly swallow planets or stars. In fact, if our sun were magically replaced by a black hole of exactly the same mass, Earth would continue orbiting almost exactly as it does today. The difference wouldn't be gravity, it would be the complete absence of sunlight. A black hole is simply a place where an enormous amount of mass has been compressed into an incredibly small region of space. Its gravity becomes so intense that beyond a certain boundary, nothing can escape. Not matter, not light, not even information, according to our current understanding. That invisible boundary has a name, the event horizon. And today, you are heading straight toward it. Surprisingly, you wouldn't immediately notice anything unusual. There would be no wall, no explosion, no giant hole floating in space. Instead, reality itself would begin to distort. As you get closer, the gravity becomes so powerful that it bends the path of light. This effect is called gravitational lensing. Light from distant stars curves around the black hole, creating glowing rings and warped images of the universe. Behind you, galaxies appear stretched. Above you, space itself seems folded. Even your own sense of direction begins to disappear. Up, down, left, right. None of it matters anymore. You are no longer moving through space. You are moving through curved space-time itself. According to Einstein's general theory of relativity, gravity is not simply a force. It is the bending of space and time caused by mass. And nowhere in the universe is that bending more extreme than around a black hole. But the strangest part hasn't happened yet. At last, you reach the edge, the event horizon, the point beyond which nothing can return. But something unexpected happens. You don't feel a shock. There is no invisible wall, no sudden flash, no dramatic explosion. If the black hole is massive enough, you might cross the event horizon without noticing the exact moment. From your perspective, time continues to move forward. Your heartbeat remains steady. Your thoughts remain clear. But to someone watching from far away, the story looks completely different. As you approach the event horizon, your clock appears to slow down. Every second takes longer than the one before. Your light becomes dimmer, redder, fainter, until you seem frozen forever at the edge. You never appear to cross it, not because you stopped, but because the light carrying your image can no longer escape in the same way. Two observers, two completely different realities, both perfectly consistent with Einstein's theory. Gravity is not equally strong everywhere. The side of your body closer to the black hole feels a stronger pull than the side farther away. This difference is called a tidal force. Around smaller black holes, those forces become enormous before you even reach the event horizon. Your body would begin to stretch, longer, thinner, until eventually, every molecule would be pulled apart. Physicists call this process spaghettification. It sounds almost humorous, but it is one of the most violent effects predicted by general relativity. Around supermassive black holes, the story is different. The event horizon is much larger. The tidal forces at the boundary can actually be much weaker, meaning you could cross the event horizon before those forces become fatal. But no matter the size, your journey has only one direction: inward. This is where science reaches its limits. Everything you've seen so far is supported by well-tested physics. But beyond the event horizon, no information can return to us. That means no one knows with certainty what happens next. According to Einstein's equations, matter continues collapsing toward an unimaginably tiny region called a singularity, a place where our current mathematics breaks down. Infinite density, infinite curvature, a point where space and time, as we understand them, no longer behave normally. But many physicists believe this is not the final answer. Quantum mechanics, the science of the very small, must somehow join general relativity. Until those two theories are united, the true heart of a black hole remains hidden. Some hypotheses suggest entirely different possibilities: a bridge to another region of space-time, a quantum core, or something we have not yet imagined. These ideas are fascinating, but they remain hypotheses, not established science. Black holes are often described as the darkest places in the universe, but perhaps they reveal more about us than about themselves. Every answer we've found has uncovered an even deeper question. They challenge our understanding of gravity, time, space, reality itself. Somewhere beyond the event horizon, the universe is keeping one of its greatest secrets. And for now, that secret remains untouched. Because sometimes, the most extraordinary discovery is realizing how much we still don't know. This is NEXORA. Explore the impossible.